Whenever we make inferences to the population from a sample, there are conditions that we must meet in order to have valid inference. That is the subject of this video. Let's talk about the issues that we must consider if we want to make an inference from the sample mean to the population mean using t-based procedures. The conditions needed for valid confidence intervals are sometimes called assumptions. I usually refer to it as conditions for valid inference, but you'll often see in the literature a reference to the assumptions necessary in order to have valid inference. The first of these assumptions, and one that is common to many types of inference, is the assumption of independent observations. That is, when we observe, including when we measure, we must do this individually for each unit. Furthermore, we cannot obtain units that might in some way be related to one another, such as, for example, obtaining measurements from members of the same family, or obtaining measurements from members of the same class. That is because the measures of individuals that are somehow related are likely to be correlated to one another, and there is an assumption for valid inference that we are not using measures that are correlated with each other. Therefore, when we randomly sample, we need to randomly sample independently, and when we measure, we need to measure independently. A second assumption is that the data are normally distributed. In fact, what is most important is that we have a normal sampling distribution. Thanks to the central limit theorem, procedures that use the t-statistic are robust to the assumption of normality, meaning we can use a distribution that is not normal. Robust simply means that the inference can be valid even if we don't exactly meet the assumption. Well, what does it take in order for us to have a sampling distribution that's normal, even if the data are not normally distributed? If the data are normally distributed, of course the sampling distribution of means will be normally distributed. If the data are not normally distributed, but the sample is large enough, say at least 30 or over 30, then t-based procedures are robust, meaning that they will still give you valid confidence intervals. When the sample size is small, for instance, less than 15, the original scores must have a distribution that is at least close to normal. Otherwise, the confidence interval for the mean will not be valid. When the sample size is moderate, between 15 and 30, the primary concern is skew or outliers. If we have positive skew or negative skew, or if we have several extreme outliers in our data, that can be problematic for moderately sized samples. If the sample is not normal, but it doesn't really look very skewed and there are no major outliers, then we can still consider our confidence interval about the mean to be valid. It is important that we know that we are obtaining valid inferences. So in the case of inferences about the mean, you need to make sure that your observations are independent, and you need to make sure that the sampling distribution of means is going to be normal using the rules that I've just discussed here.